Hello students, welcome to the subject Design Pattern, course code SCD304. Today the topic which we are going to learn is Decorator Design Pattern. In this session we will cover different topics. We will start with the introduction and then we will see a problem that we mostly face while adding or enhancing an existing object, and then we will discuss its solution. We will also consider a design principle which is proposed by a gang of four, which we need to consider while developing our apps. Then we will see the intent of decorative design pattern. We will see the different examples, UML representation, and code implementation of a particular scenario. And then at the end, we will learn the difference between the builder and as well as decorator pattern. After learning decorator design pattern, you can easily decorate already built object dynamically. It will enable you to add the additional features or responsibilities into an existing class or interface at runtime. It means that when the request of the client comes, you can add or you can put it into an existing object. To give you an idea of decorative design pattern, let's firstly understand it's in a real world. In this slide, you can see the picture of two rooms. In the left side, you can see that the room is quite empty. It has no furniture, it has no decoration piece. And when you buy or purchase something for your room and you put it inside the room, it's loaded with new furniture, for example sofas, table, and decoration pieces, and now your rooms become more beautiful, looks more beautiful. So you can see that how it's different from its original form. Similarly, we can also decorate our objects, classes, or interfaces inside of our application when there is a demand or the requirement from a client, but we have to do it dynamically or at runtime. So we will learn that how we can do it using this design pattern. Decorative design pattern attach additional responsibilities to an existing object dynamically. It allows a user to add new functionality to an existing object without changing its original structure. So you can say that it's just like the adapter design pattern which you have previously learned, but the main difference is that the adapter design pattern wraps the existing class or interface to make it compatible for another interface, whereas in the decorator design pattern, the decorator class wraps some existing class or interface to attach or to add additional responsibilities or features into it, which is the requirement or which is the requirement or the demand from the client. So this type of design pattern comes under structure category, as this pattern acts as a wrapper to existing class, just like the adapter as I told, but you should learn the difference between adapter and decorator. Okay, so decorator basically provides you a flexible alternative to subclassing to extend flexibility. What is meant by the flexible alternative solution? Basically, if you remember that when you have to extend the functionality of a class, you mostly implement the inheritance. For example, and you might be thinking that when you need to add or enhance the existing classes, let's see the few examples where there is a requirement of decoration or adding additional features. For example, let's say you have any GUI component. For example, you have a scroll bar, you have a text view, you have a button, you have a content area. So and you can add different other contents or different other piece of objects into that GUI component. For example, you can add borders, you can add scroll bar. Scroll bar can be horizontal and vertical. Similarly, borders can be of different variations. Border can be dotted, border can be plain. And similarly, for example, you are going to design a section or content area for the advertisement, but you can also decorate it by adding headers and footers into that advertisement. Similarly, the decorator doesn't mean that you add something for its beauty and look and feel. It also means that you enhance its functionality, existing functionality. For example, when you send a file to a network, maybe there is a limitation or restriction of a size, and the file compressors allows you to decrease the size of the file, and you can easily compress a file before sending it over the wire. And the file compressor doesn't even change the structure of file, but it enables the file to reduce its size. So it's also adding some additional responsibility, enhancing it by decreasing its size. So it's also the example of decorator design pattern. To understand the need and the requirement of decorator inside your application is, we will take an example of a small application. Let's say there is a text view GUI component, as mostly application require text view for input. For example, when you add text in any website, any blog, any forum, then mostly the look and feel is different, and you can enhance the text view appearance by decorating it. And how many decorations you can add? For example, let's say you can add different kind of borders, you can add different kind of scroll bars to it, because you know the text view can be simple, it can be multi-line for in taking input of large text. So there is a read of scroll bar, and similarly, to make its appearance more appealing, you can add the borders, the horizontal border, the vertical border. So basically the concept is that you are actually enhancing, you are actually decorating the plain GUI component, which is in this case is text view. Okay, let's see the requirements which we are which we have in this case to decorate the text view. It's listed that you can add three types of vertical and horizontal borders. The types can be plain, 3D, and fancy. And similarly, the variations or the options for adding the scroll bars are horizontal and vertical. It means that you can add plain border, you can add 3D border, you can add fancy border, you can add the combination of borders. For example, you can add fancy and 3D border in your text view. You can add you can add plain, 3D, and fancy, 3D or fancy, so on. Similarly, you can also add the combination of scroll bars. You can add both horizontal and vertical scroll bar in text view. And also you can decorate the text view with the combination of borders and as well as scroll bars. For example, you can add the fancy border and horizontal and vertical scroll bar in your text view. So see that how many options you have to decorate the existing text view GUI component. So while implementation of this application, you might be having the solution of multiple inheritance as you used to practice, that you can write the 15 different classes for adding or enhancing the plain text view. The number of classes that we need to write in this scenario is listed here. The one will be text view plain, the second will be text view fancy, the third will be text view 3D. These are the types of the borders, and these are the individual classes for the border. Similarly, the next class will be text view horizontal for horizontal scroll bar, text view vertical for vertical scroll bar. And to handle the combination of horizontal and both vertical scroll bar, you have to write the text view horizontal vertical. The next is text view plain horizontal. These are for the border and as well as the scroll bar. Similarly, text view plain vertical. This class shows that you can allow the class to extend with the functionality of plain border and as well as vertical border. And the next class for the combination of scroll bar and border is text view plain horizontal vertical, text view 3D horizontal, text view 3D vertical, text view 3D horizontal vertical, and so on. So these 15 classes will you have to write these 15 classes, and by writing these 15 classes you will be able to extend the functionality of text view. For example, if the client required to add the text view with the scroll bar and any kind of border, then you can extend that class or that subclass for adding its feature. You have implemented this scenario with the approach of multiple inheritance, but there is a problem with this approach, because you can see that we have to write the 15 classes. What if the number of borders increases? What if the uh, what if in this current scenario we have only three variation in border? What if they are more than three? And what if they are more scroll bars and more other objects, like for example you can add the background or so on, so you the number of classes or the subclasses that you have to write will be increasing. So the inheritance solution has an explosion of subclasses in this scenario. Subclassing is not a good approach, or the multiple inheritance is not a very good approach, because the extension is bound to the class at compile time and can't be changed at runtime. Because in the inheritance solution actually lets you to implement this scenario, but it is just a compile time solution, because you have to write the all subclasses. What if you have to add or you have to decorate the text view at runtime or dynamically? So you cannot add it or you cannot enhance the object dynamically. So we have to use another approach, and there might be another solution. We will see that how decorator enables us to decorate the existing object dynamically. So because we have known that extending an object functionality can be done statically at compile time by using inheritance. There is a concept of open close design principle that you should understand, because when adding the additional features or enhancing a class or an object, you should consider this design principle. In software programming, in object-oriented programming, the open close design principle states that the software entities such as classes, modules, functions, etc., should be open for extension but closed for modification, in a such way that an entity can allow its behavior to be extended without modifying its original structure. So basically, we will also practice this open code design principle in our application, and the decorator pattern will help us to keep this principle while implementing different scenarios. As we know that the decorator design pattern also use the concept of wrapping. So the wrapping concept is basically the containment approach, that you contain the object inside another object or class. And just like in adapter, we contain the adaptee class inside the adapter or wrapper class to make it compatible for a third interface. Similarly, in our decorator design pattern, we will have the two components. The one is the decorator, which is the enclosing object, and the second is the component which we need to decorate, and it will be contained inside the decorator class. So this more flexible containment approach encloses the component, the GUI component, in another object that adds a border or any additional feature or responsibility to the GUI component. So after getting the basic introduction of decorator design pattern, let's see its intent. The intent of decorator is to add the additional responsibilities dynamically to an existing object. Basically, a decorator provides a very flexible dynamic approach to add responsibilities to objects. And if you use multiple inheritance that we have seen in early slides, in these subclasses or the inheritance approach we can use, but it's a very static solution, because you have to write the a number of all subclasses at compile time. Whereas with the decorator, the responsibilities can be added and removed at runtime simply by attaching and detaching them. In contrast, the multiple inheritance requires creating a new class for each additional responsibility. For example, you have to when there is more feature or responsibility, you have to write another subclass, and for the combination of features, you have to again write the subclasses. Whereas the decorator make it easy to add the property as well as twice and thrice and as many numbers you want. For example, if you want to give a text view a double border, a triple border, simply attach two border decorator, whereas inheriting from a border class twice is error prone in many languages. This is the general UML representation of decorator design pattern. Inside this UML representation, you can see that we have the component. This is the GUI component that we need to decorate, and the concrete component classes shows the variation and the type of component. And for the decoration of this component, we have providing a wrapper or the decorator class or the decorator interface, and all different kind of features and decoration will be handled by taking the concrete classes of this decorator class. Now to understand the decoration of any object or the component with different features, we can start with different UML examples. You can see that in this diagram, the component that need to be decorated is basically bicycle. This is a component, and the bicycle may have different types, but in this case there are two types of bikes. The one is racing bike and the second is BMX bike. Okay, now there is a requirement that you can add the light in the bike, you can add the bell in the bike, you can also attach the training wheels in the bike, or you can also add the combination of these all additional features. For example, you can add light, and you can add bell, you can add bell and you can add training wheels, or you can add the combination of all these three decorators. So in this implementation, we have created a general decorator interface or the decorator class, which is the bike decorator, and all the decorations and all the additional features that we want to add or attach this bicycle at runtime, we have made it or declared its concrete classes. But you can see that we have not written the combination of different features as subclasses, as we have practiced in the or we have seen in the multiple head solution. So there is no such issue of explosion of subclasses. And when simply the client request or put any request, for example, he has a BMX and he want to attach the light with the bell, he will pass the BMX subclass to the decorator class, and decorator will attach the additional responsibilities. And how it's going to implement, we will understand by writing its code. Similarly, there is another UML for another scenario. In this, you can see that the object or the entity that you can decorate is a room, and the room have different types. It can be simple, it can be drawing room, it can be TV lounge, it can be VIP room, and you can decorate or add the items inside the room based on its type. So to add or attach different objects and components inside or items in the room, we will use the decorator class or the decorator interface. So for example, we can add the curtains, we can add the sofas, we can add the AC, we can add the television. So all these sub items will be the pieces of the decorator interface. So we will have a decorator interface, and it will have all the concrete classes for the individual decoration components. Whereas you can see we have not written the combination of these decorator item classes as subclasses, and we can simply attach any decoration piece inside the room by using this decorator interface. To understand the concept of decorative design pattern, let's take example from a real world. For example, you have an ice cream, and when you buy an ice cream, the shopkeeper asks you that you want to add different kind of toppings or the combination of toppings. For example, do you want to add fruits? Do you want to add chocolates? Do you want to add different different other serums? So it depends that how's your taste and what is your requirement at that time, and the shopkeeper adds the additional items or the toppings based on your runtime request. So similarly, the decorative pattern will at uh, runtime or dynamically, that when the user or the clients want any decoration, then that object will be decorated with that particular object. Okay, now to learn the coding implementation of decorator design pattern, we will take the example of a coffee. So we can say that coffee is basically an object which we want to decorate or add with different kind of toppings or variety of combinations that the client can request. And the coffee is of different types and has different variations. For example, we can say that a coffee shop offers a Starbucks coffee, which is a very famous brand, and the coffee have different several brands to offer. The one is house blend, second is dark roast, third is decaf, and espresso. So basically, coffee is of four types that user can or client they can request, and the combination of the extra toppings or the condiments options are also given to the client, which are actually optional. It means that that the client can simply request any blend from above type of coffee, but it may not request or demand for extra topping or condiment. But the options for condiments are steamed milk, soy, mocha, whipped milk. It means that client can request for extra topping or the condiment from these given options, and the each coffee has its own price, its own base price. For example, house blend has its own price, dark roast has its own price, and similarly, when you add or put inside any extra condiment, the extra cost and the charge will be uh, plus or will be uh, calculated. For example, when you request for a pizza, when you order a pizza, they ask you if you want extra cheese, extra chicken, and if you order extra chicken or extra topping, they will charge you extra. So similarly, we will see that how the decorator keep track of these additional uh, features, additional responsibilities for while adding or implementing this scenario. So how do we keep track of extra charge of each combination, and how do we charge for all combination? The first solution which may comes in your mind is inheritance. So the first option or the solution, which is inheritance, you might take a main beverage interface to represent all the flavors or the blends of coffee, and all the flavors and blends will be the subclasses or the concrete classes of this beverage class. For example, house blend, lactose, they are all the subclasses. The beverage interface will contain all the generic methods and generic behavior. For example, its description, its cost, it can be having any generic attribute or the variable, and the concrete classes will have their own attributes as well as inherit the properties of parent class. But what is the issue with this UML representation? In the previous slide, the UML we have designed for this coffee example is not appropriate, because how we can handle the condiments, how we can show the addition of condiments such as steamed milk, soy mocha, and whipped milk. So you may be thinking of writing the subclasses for each condiment and writing the subclasses for the combination of all the condiments, but the writing so many subclasses will resultantly the explosion of subclasses, as we can see in the next. If you are going to write the simple inheritance solution of the beverage with this all condiments and it's all blends, then you have to write so many classes, as you can see in this diagram. So basically you have implemented using inheritance this simple approach, but this is not recommended solution. So we have to use the decorator design pattern in this problem, so that we can avoid the explosion of subclasses, because as the blends or the flavor of the beverage increases, we have to write more subclasses, and as the condiments increases, we have to also write more subclasses. So the explosion of subclasses will be a big issue in this scenario. So we will see that how we can implement it using decorative design pattern. You might be thinking of another solution, that there is a better way of treating the condiments as an instance variable of the beverage class, that you can put, or you can inside or declare all the condiments on the features as the flag variables inside your component class. Like in this beverage class, you have declared all the flavors and all the you have declared all the flag variables as to deal or handle the condiments variable. Where do you think there is a problem with this implementation or this solution? Our goal is to simplify the maintenance, that when you need to update or the code, when the requirement changes or there is a new feature, for example the prices can change, you have to change the beverage class, the same class, and when the new condiments are there, you have to add the new methods and the flag variables, and update the cost method inside the super or the base class. For example, there's a new flavor of the beverage, for example tea, and there is a double property or double feature you have to add, single feature you have to add two times. So how you can modify, so imagine that how many times you have to modify the super class, the base class of the beverage class. So the code changes in the super class when the bug happens, or in using combination is not the recommended solution. While implementing this second solution, just to recall the design principle, that it says that classes should be open for extension but closed for modification, and apply this principle to the areas that are most likely to change. So we want our design, our classes, interfaces that are resilient to change and flexible enough to take on new functionality to meet changing requirements. So this is not the appropriate solution that you put all the extra decoration components or items as a flag variable inside the base class. So after seeing the two solutions which are not recommended and not efficient, we will see that how we can decorate the object using the decorator design pattern. To understand this scenario, let's take an example of a use case. Start with a beverage, any flavor of a beverage, and decorate it with any condiment runtime. For example, take a dark roast coffee type and decorate it with a mocha object, and decorate it with another object which is whip, and see that how its cost will be added and how its functionality is dedicated to the decorator class. In this slide you can see that initially the first is we have to understand the concept of containment approach or the wrapping approach of decorative design pattern. First, see that we have simply the object of dark roast and its base method, super method of cost. When the another topping is added, it will the decorator will wrap the dark roast object with the mocha object, and it will also add the cost of mocha to the already existing beverage blend, which is dark roast in this case. Similarly, when the another request of decorator item which is whip, see that the existing component and the existing coffee with the mocha object is again wrapped inside the decorator class, and the cost is now the combination of dark roast, mocha, and whip. So basically, the decorator design pattern use this containment approach. It adds attach the additional features to existing object gradually and at runtime. Means when the client requests, it will be attached. If the client doesn't request for any additional feature, it will not be wrapped or decorated. To design the human representation of the scenario, firstly recall or see the basic generic human representation of decorator design pattern. In this diagram, you can see there is a component interface which we have to decorate, and the concrete component shows the subtypes and the variations of component, and the decorator is the main interface, and all the decoration items which we want to or the client want to attach dynamically will be the subclasses or the concrete classes of main decorator. You can design the UML of the scenario like this. You can see there is a beverage interface, and all the flavors and the blends of beverage are the concrete classes of this interface. And to add attach the condiments as decorator items to this beverage, we have created a condiment decorator class, and all the decorator and all the concrete decorator or the condiments are subclasses of this decorator, such as milk, mocha, soy, and whip. Now you can compare it with the previous slide in slide 20, where you have use the approach one with simple multiple inheritance, that you have created the subclasses for each, not only each beverage but also for each condiment, and as well the combination of condiments. You had to write so many classes, which is certainly cause the explosion of subclasses. But in this, by using decorator design pattern, the number of subclasses we have to write are very less in number, and the decorator will use runtime and dynamic approach to attach the condiment to the beverage. We will see in the code. First is the beverage interface class. This is an abstract class. It means that we have certain functionality that we need to define here. Inside this beverage class, there is a default functionality. The default variables and the methods are defined here. For example, the description at this level, we doesn't know that which is the blend of beverage or the flavor of beverage. And similarly, the cost method is just declared, and the actual cost will be dependent on the type and the blend of the beverage. In this class, there's a first there's a decorated class, as we are adding or attaching the condiments to our beverage item or the component. So we have taken the condiment decorator. You have to extend it from your component class, which in this case is beverage class. So condiment decorator is extending the beverage class. And now there is the default behavior of condiments. We can see there is no such actual implementation, but it is showing the default behavior of decorator. This class shows the behavior. This class shows the type, flavors, or the blends of beverage class. For example, in this case, we have four kind of beverages, so we have to write the four concrete classes for each beverage. The first is house blend. It is extending the beverage class and thus way extending the default behavior of beverage. In this class, you can define its description, and also you can put or write its actual cost. So you can write the other concrete classes of beverage sub-items. Now, this is the first concrete decorator of condiment decorator. Means the options you want to provide to the client for decorating the coffee. The first is the mocha condiment. So mocha is extending its parent condiment decorator. And second is there is there is the basically there is the composition of your component which you want to decorate or wrap. As we have said, the decorator use the containment approach, the wrapping approach. It wraps the object that you want to decorate. So to wrap it, you have to pass or you have to instantiate the component object, which in this case is beverage. So we have declared the beverage object inside it. The next is this constructor class, where we are passing the reference of beverage item here. The next is the definition of description of this condiment, and the cost method is actually defining the cost of the mocha condiment. Similarly, you can write the other variations of condiment decorator, such as milk, and such as soy. I have written in this example the one concrete class of decorator and one concrete class of blend, as shown in previous slides. You can write the other concrete classes by seeing these classes. I'm assuming that you will simply write the other concrete classes of beverage and condiment decorator by following the last two classes. So let's see how inside the main function we can use the decorator class to decorate the component. In this case, the component is our beverage, and the beverage have four types, and for the decoration options or toppings we have different condiments, and the condiments have also different variations. So let's start to check the flow. Firstly, in first statement inside the main method, the beverage is instantiated with its concrete class espresso. It means we are creating the beverage of espresso type, and at this level we are printing its cost, and its cost will be original. No extra condiment is attached. It will depend upon the requirement. So let's say we don't have any requirement to add any extra condiment to the espresso. So the espresso will maintain its original and super cost. And the next line shows that we are creating the beverage 2 beverage, which is of type dark roast. And the beverage 2, in beverage 2 we have to decorate it with the condiment mocha, and then again mocha means we are going to add double mocha. Here we can add so much, so many number of condiments that we want to add. We will wrap it, we will decorate it, we will contain it inside the decorator to attach it with that concrete decorator. And the beverage too, after adding the double mocha, will also add the whip decorator. So see what's happening here. After creating the beverage 2 of type dark roast in second line, we are passing it with the new mocha, which is concrete decorator. Now this will wrap it with the mocha. Similarly, to add a double time, we will again pass it to the new mocha concrete decorator. And if we want to add the third time mocha, we can also pass it for the third time. So it will add the three layering or the three type of wrapping. And the next decoration is whip, and we will also pass the same beverage 2 instance to the whip decorator, complete decorator. And now after printing, we can confirm by logging that the cost is the final cost of the beverage 2 is the original cost of the dark roast plus the double mocha cost and plus the whip cost. And the third use case, in third use case, we can see that the beverage 3 is of type house blend, and it's decorated with soy, it's decorated with mocha, it's decorated with whip. Then to decorate it with any condiment, you have to pass it to that concrete decorator instance. So basically you can see we are using the combination of inheritance as well as composition approach in this decorator design pattern. Instead of just simple hand solution, the subclasses, the number of subclasses are very much in number, and explosion of subclasses was the main issue. So using the combination of composition approach and as well as the inheritance approach, we have implemented it in a very efficient way. Using the concrete decorator, we are wrapping the main our main object that we want to add with the additional feature or additional condiment here. And the attributes are calculating, the properties are calculating based on its additional properties that we are adding at runtime. So you can see that at main, when the client request, we will wrap the component or the object with that concrete decorator. So it's a very dynamic and runtime approach. This is basically the output window, and by seeing the output, you can easily understand the flow of all your application. You can see that for first use case, we haven't added any extra decoration or any condiment. So simple. The beverage type is espresso and its original cost is displayed. The second use case was the request of dark roast coffee, and you can see that two times mocha is added and one type whip is added as it's requested in the main method, and the final cost is accumulated. Similarly, for third use case, the coffee type was house blend, and the decoration we have added is soy, mocha, and whip, and the final cost is calculated. You might confuse the decorator design pattern with the builder design pattern, because you can see decorator is attaching the different sub items or sub component to your main component, and whereas builder is also building the different sub items of component. But there is many big difference in both design pattern, because we know that all elements and the components that we are going to build inside the builder patterns are mandatory and are must. So if one item or sub item is missing, the final product will not be built. So the object will be incomplete or inconsistent if any item, any sub item is missing. Whereas the all items and the decoration items, the combinations or the features inside the decorated design pattern are optional. For example, when you want to buy an ice cream, the ice cream is actual the final product, but it's your choice, or it's very optional that you want to add extra cookie, extra topping, extra chocolate on the ice cream. So it's optional. Similarly, the elements inside the decorator are optional. They are just to enhance or add the additional features and responsibility to existing already built object. So this is the bonus or the extra functionality that we are handling using the decorator design pattern. Okay, so let's summarize that what we have learned in this session is basically we have seen the main design principle. This design principle, open close design principle, is applicable to all design patterns, and it says that the classes should be open for extension but closed for modification. Using the decorative design pattern, we have achieved the flexibility because we are changing the behavior by extending it without changing its original structure. And we are also using the combination of composition and multiple inheritance approach. Basically, the delegation is used. You can see that the main component is delegated to the concrete decorators to attach and add the new behavior, new functionality, new features, new responsibilities at one time. So a set of decorator classes or concrete decorator classes are used to wrap or contain the concrete components.